Okay, in this video we are going to talk about rationalizing the denominator. So before we start that, I just wanted to do a quick review over the operations with radicals. We did this in a video last week, but just a quick review. So first of all, we can add and subtract radicals. And so for example, if we had the problem 7 square roots of 3 minus 5 square roots of 3, again, I'm allowed to subtract these because my root is the same, and essentially this says I have 7 of these square roots of 3, I have 5 of these square roots of 3, and I want to take away 5, and 7 minus 5 would be 2 square roots of 3. Okay. Another example, if I had 3 times the square root of 8 plus 2 times the square root of 2. In this case, right now, I cannot add them together because my roots are not the same. The square root of 8 and the square root of 2 are two completely different things. But I can break down the square root of 8 and pull something out, and it probably will turn into the square root of 2. So just a reminder how to break that down. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. So the square root of 8 is 2 times 2 times 2. And we want to take out pairs here, so I want to take out a 2. Just a reminder, there's already a 3 out there. So the 2 up will out, and I'm going to multiply by the 3. So it's going to be 6 square roots of 2 plus 2 square roots of 2. And if I have 6 of them and I add 2 more to it, I get 8 square roots of 2 as my answer. So that's adding and subtracting radicals. To multiply radicals, the rule is you may multiply outside numbers with outside numbers and inside numbers with inside numbers. So for example, if I had the problem, the square root of 2 times 3 square roots of 5 minus the square root of 7. If I'm distributing square root of 2, I'm going to multiply 2 is an inside number, 5 is also an inside number, so I'm going to keep the 3 on the outside and multiply the 2 times 5 to get 10 on the inside. For the next part, when I do square root of 2 times the square root of 7, it's going to be minus, these are both inside numbers, so I can multiply them together and get the square root of 14. At this point, I cannot add these together because this is the square root of 10, this is the square root of 14. If I went to go break down 10, it's just 2 times 5 and there's nothing to take out. If I went to go break down 14, it's just 2 times 7 and there's nothing to take out. So we cannot add them together. So that is your answer. Okay, so we went over addition problems, subtraction problems, multiplication problems. We never went over division problems because, essentially division is rationalizing the denominator. So this is getting into the material for section 7.5. The big thing you have to know about radicals is that we're not allowed to have a square root in the denominator. So because of that, since we are not allowed to have a square root in the denominator, we have to fix it. The way we fix it is we rationalize it, okay? So the way we fix it is to rationalize. Okay, so our first problem is going to be 3 over the square root of 2. The reason why I was saying this is like division is because this is like 3 divided by the square root of 2. We are not allowed to have the square root of 2 in the denominator, so the way we fix it is by multiplying it by something so that we can take the square root of it. So I'm going to take my problem, 3 times the square root of 2, and I'm going to multiply it by, I want to multiply the bottom by the square root of 2. And the reason why is because when I multiply the square root of 2 times the square root of 2, those are both inside numbers. So I can multiply them together, and I get the square root of 4, because 2 times 2 is 4, and the square root of 4 is just 2. So I no longer have a square root on the bottom. Okay, so I just did the problem just to show you, but the thing is, I'm not allowed to just multiply a problem by a number. I have to keep it equal, and the way to keep it equal and just to essentially be multiplying by 1 is to multiply whatever you do on the bottom, you also have to do to the top. So on the top, 3 times the square root of 2, this is an outside number, that's an inside number, so I get 3 square roots of 2. And this is my answer. I can't reduce this because this is an inside number, this 2 is, this is an outside number. So that's my answer. Okay, so just to show you, I didn't actually change the problem. This 3 divided by the square root of 2 is a decimal, 2.12132, yada, yada, yada. This over here, 3 times, 3 times the square root of 2 divided by 2 is the exact same number. So I didn't actually change it. I just rewrote it, essentially, without the square root on bottom. Okay, so just a real quick recap. This is my problem, 3 square roots of 2. This is how I rationalize. When I multiply it all out, notice I don't have a square root left on bottom. So let's do some more of those. If I had the problem, 2 times the square root of 2 over the square root of 5. We have a problem here. We have the square root of 5 on bottom. I'm not allowed to have the square root of 5 on bottom, so the way I fix it, I'm going to rewrite my problem. 2 times the square root of 2 over 5. Square root of 5, excuse me. I need to multiply by the root that's on the bottom, not the root that's on the top. It's fine to have a root on top. So I need to multiply by the square root of 5 on both bottom and top. Again, I picked the square root of 5 because it's the bottom number. Whatever I do the bottom, I also have to do the top. And when I go to multiply this, I get 2 square roots of 2 times square root of 5 is 2 and 5 are inside numbers. This 2 is on the outside, so it's 2 square roots of 10 over the square root of 5 times the square root of 5 is the square root of 25. And I can simplify that. The square root of 25 is just 5. And that's my answer. I can't divide this 10 and 5 because 10's an inside number, 5's an outside number. Okay, sorry. Let's do another problem like that. Number 3. If I had the problem 5, how about the square root of 5 over the square root of 3. Take a second and see if you can figure out what you need to multiply by to rationalize that. Okay, so my problem, square root of 5 over the square root of 3. To rationalize, I need to get the root off the bottom. So I'm going to multiply by the square root of 3 on bottom and on top. So on top, I get square root of 5 times square root of 3, which is square root of 15. On bottom, square root of 3 times square root of 3 is square root of 9. Square root of 15, I can't take the square root of it, and I can't really break it down because I'm just left with 5 times 3. So it's just going to be the square root of 15. On bottom, the square root of 9 is 3. I can't divide those because that's an inside number. That's an outside number. So that's my answer. Okay, so notice if my problem looks like this. The square root of 3 over 2. This is really similar to the one above it. It just looks a little bit different. I'm taking the square root of the whole thing, the 3 on top and the 2 on bottom. So I can rewrite this as the square root of 3 over the square root of 2. And now this looks just like, or very similar to the problem above it. So take a second and pause the video and see if you can rationalize that, get the right answer, and then come back whenever you're finished. Okay, so you should have multiplied by the square root of 2 over the square root of 2. So on top, I get square root of 3 times square root of 2 is the square root of 6. On bottom, the square root of 2 times the square root of 2 is the square root of 4. Square root of 6 I can't do anything with, but square root of 4 is 2. And so that's my answer. Okay, so that's rationalizing square roots. Notice that all those problems we just did all had square roots. Let's talk about how to rationalize a cube root now. Okay, so it's essentially the same idea. It's just I got to do a little bit more work to rationalize it. So for my problem, if I had 1 over the cube root of 2. Okay, so notice, if I took my problem and I rationalized, just like before, the cube root of 2 over the cube root of 2. When I would go to work this out, I would do the cube root of 2 times the cube root of 2, and I'd get the cube root of 4. And the cube root of 4, you can't take the cube root of because it's 4. 2 times 2. You have to take out like 3 2's, right? So what we have to do for cube roots is we have to rationalize 2 times. Okay, so I have to do it again. I have to multiply again by the cube root of 2 over the cube root of 2. So notice I rationalize once here, rationalize the second time here, because on bottom I have the cube root of 2 times the cube root of 2 times the cube root of 2, which is the cube root of 8, and the cube root of 8, what number times itself 3 times is 8, is 2. So that's the reason why I have to rationalize twice, is to get the 3 2's so that I can pull it out. Okay, and then we go ahead and work out the top. 1 times the cube root of 2 times the cube root of 2 is the cube root of 4. And I cannot take the cube root of 4, so that's what's going to be on top of my answer. The cube root of 4 over 2. Okay, so let's do a few of those. If I think this was number 5. If I had the problem, the cube root of 2 over the cube root of 3. So to rationalize, I need to multiply by the root on bottom 2 different times. So let me rewrite my problem. The cube root of 2 over the cube root of 3. I'm going to multiply by the bottom, the cube root of 3 over the cube root of 3. And again, I have to multiply 2 times. So multiply by the cube root of 3 over the cube root of 3 again. When I work out the top, the cube root of 2 times the cube root of 3 times the cube root of 3. These are all inside numbers, so 2 times 3 times 3 is 18. So the cube root of 18. On bottom, the cube root of 3 times the cube root of 3 times the cube root of 3 would be, they're all inside numbers, 3 times 3 times 3 is 27. And the cube root of 27 is just 3. So this is my answer. So probably if you were in class at this point, somebody for sure would have said, do I actually have to write the cube root of 27? Because I know that since I have 1, 2, 3 3's there, it's just automatically going to be 3. And yes, that's totally fine. If you can see that you don't need to actually multiply these out, you just know for sure it's going to be the cube root of 3, that's awesome. That's fine. I would go ahead and check it, though, every time you do it, though, because, like, you might have forgotten and only did it once and then just went ahead and wrote 3 on bottom, and then the number on top would have been wrong. So, yes, you can skip this step right here. I need to see this right here, and I need to see your answer, but you can skip that middle step if you feel like you're ready to skip that middle step. Okay, let's do another one. If I had the cube root of 5/7. So again, this is written all as 1. It's taking the cube root of both the top and the bottom, though, so I can go ahead and rewrite it as the cube root of 5 over the cube root of 7. And then to rationalize, I need to multiply by the bottom. It's fine to have it on top. I'm not allowed to have it on bottom. So I'm going to multiply the cube root of 7 on top and bottom, again, 2 times, since it is a cube root. And this is actually probably a really great example of one you might not actually multiply by, because on top, these are all inside numbers, 5 times 7 times 7. So it's going to be the cube root of 245 on top. On bottom, it's going to be the cube root of 7 times the cube root of 7 times the cube root of 7. So 7 times 7 times 7. you get this big number, 343, and you can write it as the cube root of 343 if you wanted to, but you may not know off the top of your head what is the cube root of 343. Well, I know I just multiplied 7 times itself 3 times, so it's going to be a 7 on the bottom. So the cube root of 245 over 7 is your answer. Okay, so far we've gone over how to rationalize a square root, how to rationalize a cube root. The last thing I'm going to show you is how to rationalize if there's more than one root on bottom. Okay, so if I had the problem 5 over the square root of 3 plus 2, and I wanted to rationalize that problem. If we just tried to rationalize it like before, this is, the square root of 3 is on bottom. Again, to rationalize a square root, I only have to do it one time. So if I tried to go ahead and just multiply by the square root of 3 over the square root of 3, this is not the way you do it, so don't write this in your notes, but I just want to show you what happens. So this is like 2 terms here, and this is 1 term, so I have to like distribute on the bottom. So the square root of 3 times the square root of 3 gives us the square root of 9, which is awesome because I know the square root of 9 is 3, right? But here, the square root of 3 times 2, this is an outside number, that's an inside number, I get 2 square roots of 3. So on bottom, you would end up with a 3 plus 2 times the square root of 3, and that didn't fix my problem. I still have a square root on bottom. So it's not going to work that way. If I try to do it twice, it's still not going to work. I'm still going to have this weird thing over here, and it would actually mess up this one too. So what we have to do instead is we have to use the conjugate. Okay, we talked about this last week in the video about the operations with fractions with multiplication. So the conjugate is, if I had 2 things, a plus b, the conjugate would be a minus b. Okay, so notice it's the same thing inside, it's just the signs are different. And it works out because it kind of gets rid of all the ugly stuff. And we did this on one of the problems last week. It got rid of all your radicals, and we ended up with just this pretty number at the end. So for this case, if I had the problem, the square root of 3 plus 2, the conjugate would be the exact same thing, the square root of 3 and 2, but a minus sign in the middle. Okay, so square root of 3 minus 2. And I use that conjugate, I go ahead and multiply by it, and it's going to make my radicals in the denominator go away. So let's do an example like that. Let's do the same problem, the 5 over square root of 3 plus 2. And let me multiply by the conjugate. So again, the conjugate is the square root of 3 minus 2. And I got to do on bottom also. I'm sorry, on bottom and top. So on top, I'm going to multiply. 5 times the square root of 3 is 5 square roots of 3. 5 times 2 is 10, and it's a minus sign. On bottom, we have to FOIL this out. Square root of 3 times square root of 3 is square root of 9. Square root of 3 times negative 2 is negative 2 square roots of 3. Square root of 3, I'm sorry, now I'm at 2. 2 times the square root of 3 is positive 2 square roots of 3. And 2 times negative 2 is negative 4. On top, there's nothing we can do here. We're just left with 5 square roots of 3 minus 10. On bottom, there's a few things I can do. The square root of 9 is 3. Negative 2 square roots of 3 and positive 2 square roots of 3, that's 0. And then minus 4. So on top, it's going to be 5 square roots of 3 minus 10. On bottom, 3 plus 0 minus 4 is negative 1. And lots of times, like if this was like a 7, there's nothing you can do here. Lots of times you just leave your answer like that. Since this is just negative 1, the way that we divide anything by negative 1 is essentially you just change the sign. So I'm going to divide each piece. I'm going to do 5 square roots of 3 divided by negative 1 and get negative 5 square roots of 3. And then negative 10 divided by negative 1 is positive 10. And that is your answer. Okay, let's do another one like that. So just a real quick recap, you multiply by the conjugate on bottom and on top, and you multiply it all out and just work it out. Okay, I believe that was problem number 7. So let's move on to problem number 8. If I had the problem square root of 5 over 3 square roots of 2 plus 4. I need to get rid of the root on bottom, so I'm going to multiply by the conjugate. The conjugate is 3 square roots of 2 minus 4. Okay, so 3 square roots of 2 minus 4. Whatever I do to the bottom, I have to also do to the top. When I go to multiply this all out, square root of 5 times 3 square roots of 2 is 3 square roots of 10. Square root of 5 times negative 4 is negative 4 square roots of 5. On bottom, 3 square root of 2 times 3 square root of 2. 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4. 3 square root of 2 times negative 4 would be negative 12 square root of 2. Positive 4 times 3 square root of 2 is positive 12 square root of 2. And positive 4 times negative 4 gives me negative 16. On top, 3 square roots of 10, 4 square roots of 5. I can't add or subtract them right now because they don't have the same root. I can't really break it down and take anything out because when I break down 10, I just get 2 times 5, and there's nothing to take out. 5 doesn't break down, so I can't take it out. So let's simplify the bottom. 9 times the square root of 4. The square root of 4 is 2, so this is just 9 times 2, which is 18. Negative 12 square roots of 2 and positive 12 square roots of 2, they cancel out, or it's 0. So 18 plus 0 minus 16 gives me 2. So my answer is 3 square roots of 10 minus 4 square roots of 5, all divided by 2. This 2 is an outside number. If I look at my outside numbers up here, the 3 and the 4, they don't both divide by 2. So that's my answer. And generally, that's kind of how it works out. Okay, so I hope that is helpful. So just a quick recap. You cannot have a square root on the bottom. So the way you get rid of it is to rationalize. If it's just a square root problem, you just multiply by the square root on bottom and top. If it is, if it is a cube root, you have to multiply by the cube root on bottom and top 2 times. If it is something with a plus or minus sign in the denominator, you have to multiply by the conjugate to work it all out. Okay, so that is all of section 7.5. I will go ahead and post a video that I find on YouTube with some more extra practice of explaining rationalizing. So if you're still struggling, please feel free to watch this video again or see the other video about rationalizing the denominator. And feel free to email me if you have any questions.